Hello students, very good evening. Guys, first of all, let me introduce myself. I am Arvind Kalia. And I have done my master's in mathematics from IIT Delhi. Okay, so right after that, I am into teaching only. It's been now about 10 to 11 years that I'm teaching maths. It was more of my passion to teach maths, so that is why I chose this line. So here, today I'm here to give you like a brief webinar on sequence and series. Okay, so just to make you realize that this topic is really good, easy and quite important. It really develops your IQ first of all. Very little intricacies will be there, which if you just think upon, you will feel really good that you learned something out of these little intricacies. Okay, so today I'll make you aware of those little intricacies of this topic. Let me tell you the flow first of all. Guys, first I'll just cover one example of AP and one example of GP and try to tell little fundamentals which are general in sense, but they are used here in particular. After that, I'll straight away come to AM greater than equal to GM, which is quite important relation when it comes to maximum or minimum values. It will be used here in this chapter, and in 12th class, there will be a chapter called Maxima and Minima. It will be used here as well. So quite important. So I'll be covering about 4 to 5 examples on AM and G. What I'm assuming is that you already have little knowledge of AP, GP, AM, and GM. So far, because it's like August, and by now, almost everyone has covered sequence and series in their respective schools or coachings. So I'm assuming a little bit that you are already aware of the basics of these 4 things. So with that, let's start, guys. See, my first example for you is this one. If a square plus 9b square plus 25c square is equal to 15bc plus 15ac plus 3ab, then we need to prove this thing. 1 by A, 1 by B, 1 by C is in AP. Guys, let me just recall one of the very basic identities. A square plus B square plus C square minus AB minus BC minus CA. It is equal to half time A minus B whole square plus B minus C whole square plus C minus A whole square. This is one of the very important identities. If you already know this, good, very good. Otherwise, just note it down and memorize it badly. It is really important. You may easily verify by opening up the right-hand side. It will come out to be equal to left-hand side. Now, how is it going to help me in the question? Guys, just bring everything on left-hand side and you will see a little connection of this question with this identity. Like, see, square, 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 square. Like this. Then product of first 2 terms, product of second and third term, product of first and third term. Don't you think it is a product of second and third term, 3b and 5c? Here also it's a product of 5c and a, and it is a product of a into 3b. Try to see. 3b 5c minus a into 5c minus a into 3b. So if you can relate, it is exactly of same format. So whenever you see square, 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 then product of 2, product of 2, product of 2, you always relate it with this important identity. And immediately using this identity, we can write it as half time a minus 3b whole square plus 3b minus 5c whole square plus 5c minus a whole square. equal to 0. Just have a look, compare it. Very good. Now guys, don't you think the question is almost over? See, it's a square, so it's a non-negative term. It is also a non-negative term. It is also a non-negative term. But their sum is 0. Now, if the sum of non-negative terms is 0, the only possibility is that all the terms must be 0. So from here we get A equal to 3B equal to 5C. A equal to 3B, 3B equal to 5C, 5C equal to A. That is, all of these three terms are equal. Now after that nothing is left. It is a standard method that whenever we see such equality, like involving 3 or 4 terms to be equal, we always call all of them to be equal to K and find everything in terms of K. So my A is K, B is K by 3, and C is K by 5. It's one of the standards. Always remember, when you have 3, 4 or 5 terms given to be equal, you always call all of them to be equal to K. As they are equal, they must be equal to something. Let that be K. We need values of 1 by A, 1 by B, 1 by C. So guys, don't you think it's like we have these values? What is 1 by A? 1 by K. What is 1 by B? 3 by K. And what is 1 by C? It is 5 by K. We know 3 numbers are in AP when sum of first and third term is equal to twice of middle term. Sum of first and third term is equal to twice of middle term. Yes, it is so. It is 6K equal to 6K. So these 3 numbers are in AP. That is all. See, concept is very simple, that 3 numbers are in AP if sum of first and third term is twice of middle. So in the very beginning, we knew that we have to prove that 1 by A plus 1 by C is double of 1 by B. But to do that, we need to have some information about A, B and C, for which we were given this information. And we wanted to derive some information about the values of A, B and C. So first we used that identity to develop this relation. From here, we used very old fundamental, saying all equal to K, we found A, B and C in terms of K. And then we just proved this thing. That is all about first question. So AP, but involving 2 concepts. One is this, one is this. Okay. Such questions they are going to ask you in competition, where concept will be very simple, but it will be using 2-3 fundamentals which are general. You need to know such fundamentals. Okay. Now let us do one question upon GP. If A, B, C are 3 distinct real numbers in GP such that this holds, then prove that X belongs here. Now with such questions, normally the problem which students feel is, sir, how to start the problem? ABC are in GP, we understand, but it satisfies this condition. Now how are we going to use that this condition is satisfied and hence find X? The basic utility of GP is that the number looks like A, AR, AR square and so on. So if A, B, C are in GP, clearly I can write B as AR, C as AR square. So we have this equation. Now clearly A is not equal to 0 because they are distinct real numbers. If A is 0, A, B, C all will be 0. So A cannot be 0. So certainly we can cancel it. So we get 1 plus R square equal to X into R. Now, second step. So what should we do now? We used ABCR in GP, but now what should I do to find X? Guys, I have to observe it's first of all a quadratic in R. So this much though we can think that we can write it like this. Now the next step is very interesting. Point is, we are given that such numbers A, B, C in GP exist for which this holds. It means from here we should be able to find R. We should get the real value of R because we are given such ABC exist which satisfy this condition. Now it's a quadratic in R. When will we get real value of R? When D is greater than or equal to 0. Concept of quadratic. Basic, easy concept, but it should strike you. That is the point, right? So when we put D greater than or equal to 0, we get B square minus 4AC greater than or equal to 0. Now from here you can easily find X. Let me just do it. X square plus 1 minus 2X minus 4 greater than or equal to 0. That is X square minus 2X minus 3. Certainly we can factorize it. X plus 1, X minus 3 greater than or equal to 0. Using wavy curve, I hope everybody knows wavy curve. We get X belongs to minus infinity to minus 1 union 3 to infinity. Let me just recall if you are not getting what is wavy curve. We used to do it like that. Plus, minus, plus. We want greater than or equal to 0. So these are my solutions. Right? Recalled it? Good. So that is what we call wavy curve method. We use it to solve inequalities. Guys, we got almost everything. But observe, we have closed bracket here. Still something is missing. Distinct. Guys, a GP has distinct real numbers when R is not 1 and R is not minus 1. Okay, then GP has distinct terms, 3 terms distinct. Because if R is 1, then to every term will be A. If R is minus 1, then the terms will be A, minus A, plus A, minus A, and so on. important point. Had it been given in objective and one option is this and one option is this, I'm pretty sure many of you would have marked this one. So you got to observe the question very particularly. Each and every information have some like background. So we got to use R is not 1 and minus 1. So when R is 1, then clearly from here, you get X equal to 3 using 1. And when R is minus 1, X is minus 1. We don't want R to be 1 or minus 1. So these values must be rejected, and hence X belongs to minus infinity to minus 1, union 3 to infinity. So guys, what did we learn in this question? Number 1, quadratic ka concept. Very important. A quadratic in R is given, or we obtained it, and we are given in the question that this quadratic must give me some R. How? Because we are given that ABC in GP exists for which this holds. That is, R exists for which this holds. So when will quadratic hold? When D is greater than or equal to 0. That is first thing we learned. Second, guys, you need to be very particular when reading the question. Each and every information has some role to play. Distinct. So R cannot be 1 or minus 1. So in the questions of GP, always remember, if the terms are given to be distinct, you have to make sure that R is neither 1 nor minus 1. Good. So that was one question on GP in which I tried to just revise some fundamentals which are quite general in nature. They can be used anywhere. Now guys, let's move toward AM and GM. Statement is very basic, that this. Let me just give you a few cases of that first of all. For positive numbers, first of all, this relation always holds only for positive numbers. We find GM only for positive numbers. We do not find GM for negative numbers. Okay, so whenever we use this relation, we use it for positive numbers. For two numbers, this relation becomes this. AM of two numbers is greater than or equal to GM of two numbers. Now for three numbers, this is the AM of three numbers and this is the GM of three numbers. AM of three numbers is greater than or equal to GM of three numbers. Similarly, for four terms, this is the AM of four numbers and this is a GM of four numbers. So AM of four numbers is greater than or equal to GM of four numbers. Similarly, general. AM of n positive numbers is always greater than or equal to GM of n positive numbers. Now this is like particular cases for this thing. When we have two numbers, when we have three numbers, four numbers, or in general. Now, before doing questions upon this relation, if you have done it so far, you must have felt that sometimes we don't get that how will it come in our mind that we should have used this relation in the question. Sir, we read the question, we understand it, but we are unable to do it. Moment we see the solution, there it is written, applying AM greater than or equal to GM. And then we think, oh, how come that didn't come in my mind. So that is a basic tragedy with this AM greater than equal to GM. It generally doesn't strike your mind. Let me tell you, there are 3 very evident hints which are, if present in your question, you have to use this relation. 3 evident hints. Okay. Let me just tell you those 3 hints. Then I'll come back to this page and tell you one more thing. Number 1, in the question, minimum value of sum or maximum value of product of something is asked. Okay. Normally, if in the question minimum value of sum or maximum value of product is asked, it's the first hint that AM/GM is going to be used. Second and most important hint, terms given in the expression. By that I mean, say question is find the minimum value of this sum, and the terms involved in that expression are positive. Clear cut, use AM greater than equal to GM. Why? Because this holds only for positive numbers. So if in the question they want you to apply this thing, they will make sure that each and every term is positive. And third, product of terms or sum of terms which are involved in the expression is good. Now what do I mean by that? Just wait, I'll tell you. Okay, now these are 3 hints. Before doing questions and re-emphasize these points, let me just come back here and tell you one important point. If I talk about first point, AM is greater than equal to GM. Guys, in AM, sum is involved, and in GM, product is involved. Clearly greater than equal to means this is the minimum value of this, because left hand side is greater than equal to right hand side. Okay, so first thing is, from such inequality we will get sum is greater than equal to something. So we will get minimum value of sum. Now if you see it otherwise, this is less than equal to this. So here we are going to get product is less than equal to this. So we are going to get maximum value of product, because product of AB will be less than equal to that. So that will be the maximum value of AB. Okay. So question will always be like, find minimum value of sum or find maximum value of product. Okay. Let me just re-emphasize it and then I'll come to question. Like here, if I am asked minimum value of A plus B plus C, I can easily find, because A plus B plus C will be greater than equal to 3 times this. So this must be minimum value of that. And if I am asked maximum value of A into B into C, it will be power 3 here, less than equal to A plus B plus C by 3 whole power 3. ABC power 1 by 3 less than equal to A plus B plus C by 3, right? I'm just rewriting it. Yahan se you will get this thing. So what does it imply? That ABC is less than equal to this. So this must be maximum value of ABC. So for product, you will get maximum value. For addition or sum, you will get minimum value. Let me just show you that in the examples. See, if x1, x2, so on to x50 is 1, their product is given to be 1, then find minimum value of their sum. Simple. Try to fit in the three criteria. Minimum value of something is asked. Yes. Terms. Use applying AM greater than equal to GM on X1, X2, so on to X50. You apply AM, GM on the terms which are involved. Okay. So what will be their AM? Their sum divided by 50. This is the AM of these numbers, greater than equal to their product raised to power 1 by 50. That is their GM. Guys, try to see. This is nothing but 1. It is given. Question is done. X1 plus X2 so on to X50 is greater than equal to 50 times 1. Done. So 50 is the minimum value of this addition. Right? So let me just conclude it. In question, they were asking for minimum value of sum, which is X1 plus X2 so on to X50. Second, terms involved, that is X1, X2, so on to X50, were given to be positive. Third, product of the terms, product of these terms, X1, X2, so on to X50 is good. It is given to be 1. So all the criteria are matched. So you just apply AM, GM on these 50 numbers. Don't you think second question is also of same nature? Maximum value of this product is asked. Second, terms involved are positive and sum is good. Exactly same. Applying AM greater than equal to GM on X1, X2, so on to X50. What do we get? This sum divided by 50. This is the AM of these numbers. It must be greater than equal to GM, which is this. Now guys, this sum is good. It is 1. And what do we require? Maximum value of this product. So just keep this 50 power to the left hand side. Bring it to the left hand side. So you will get 1 by 50 raised to power 50 is greater than equal to this product. So clearly, this is the maximum value of this product because it will always remain less than equal to this. So guys, by these two examples, what I'm expecting is you must have understood two important points about AM/GM. Number one, how to identify that this question will be done by AM/GM. These 3 hints, that's all. Second, when sum is asked, they will always ask minimum value. When product is asked, they will always ask maximum value. That's all. right? Okay, guys. So if you have understood this thing, let me give you one question. Try to do it. I'll give you 30 seconds, okay? Not more than that. Try this question. By the way, it's the previous year IIT previous year question. Just keep it simple. Just try to apply the fundamentals which I just told you. Good, very good. Try to see product of n positive numbers is unity. Two good things are there. Numbers are positive. Product is unity. Unity means 1. Numbers are positive. Product is good. Okay. Then their sum is. So they are comparing product and sum. AM GM का सवाल लग रहा है. Done? Very good. So guys, let the numbers be x1, x2, so on to xn. Guys, they are given to be positive. That's the biggest hint, right? And the product is unity. That is, product is good. AM, GM, nothing else. So we will apply AM greater than equal to GM on these numbers. Important, AB. You apply AM greater than equal to GM on the terms which are involved in the expression. So what will be their AM? AM of x1, x2, so on to xn is this. And what is their GM? Their product raised to power 1 by n. Guys, product is given to be 1. No? So question is done. x1 plus x2 so on to xn is greater than equal to n into 1. So clearly this sum will always be greater than equal to n. That is, the sum cannot be less than n. Such a simple question. It came in IIT, previous year IIT question, right? So AM, GM, quite important category. The only thing is you should know when to apply it and how to apply it. Regarding when to apply it, I just told you, you need to see those 3 hints. How to apply it? You apply it on the terms which are involved in the expression. Let me give you 2 or 3 more examples to further clarify how to apply it. Read the question. If alpha belongs to 0 to pi by 2, then root of x square plus x plus this by this is greater than or equal to. Guys, see, number 1, greater than or equal to means they are asking minimum value. Minimum value. Number 1 hint. Second, थोड़ा आप गौर फरमाइए. The terms involved in the expression. There are 2 terms which are involved. Terms involved in the expression are positive. Root of any number is positive. Root never gives negative output. So both the numbers are positive. Third, what about their product? This will cancel out. You will be left with tan square alpha. Product is also good. Product is constant because all the variables are being cancelled out. All the 3 hints are there. So I don't think you should be having any doubt regarding AMGM. How to apply? We apply AMGM Please everybody listen carefully on the terms involved. That is on this term and this term. We apply AMGM on the terms which are involved. So two terms are there. So guys, what is their AM? It's their sum divided by 2. It must be greater than equal to their GM, that is root of their product. Cut. So guys, what do you get? The minimum value of this thing we require. Yes or no? You want minimum value of this thing? It is automatically created here. So 2 cross multiplied root of tan square alpha. Guys, little but important concept. Square root of x square is not x. What it is? Yes, it is mod x. Okay, square root of x square is always mod x. It's never x, it's mod x. So this thing becomes 2 times mod tan alpha. And now guys, try to see this is playing role. Every information has some role to play. This is telling you that alpha lies in first quadrant. So this tan alpha is a positive quantity. And if it's a positive quantity, mod will open as such. So minimum value is 2 tan alpha. That is option A. You won't believe such a simple question. It's also a previous year IIT question. Such a simple question is also a previous year IIT question. Okay, not even like mains, IIT. So such basic questions are asked sometimes on AMGM. So it's very important inequality. Now, slowly, let us move toward bit better questions. This one. First, read the question carefully and immediately realize, yes, it will be easily done by AMGM. This thing is a major hint because this thing is telling me that this are positive. If they have same sign, then x by y, y by z, z by x will be positive. So the terms involved are positive, minimum value is asked, and clearly their product is also very good. It is cancelling out, product is 1. So I'm straight away going to apply AM greater than equal to GM on x by y, comma y by z and z by x, the terms which are involved. It's done now. Their sum divided by 3 is greater than equal to their product raised to power 1 by 3. And it's done. Cut. Cancelled. Cancelled. It is 1 now. So clearly this 3 will be cross multiplied and you are going to get minimum value is 3. Okay. So by now I'm expecting you know when to apply AMGM and how to apply AMGM. Now we are going to do some good questions. 2 questions I have selected for you which are like good questions. Okay. Number 1 is this. Read the question. This is first level of good question. If x, y, z are positive numbers, then we got to prove that x plus y into y plus z into z plus x is greater than or equal to 8xyz. Number one is clear. The question is of AMGM. When to apply wala part is clear. Terms are given to be positive. We need to prove something is greater than or equal to something. On one side, sum of this is there, and on one side we have product. So kind of it's like almost clear that it is a question of AM and GM. But how to apply? Guys, see. First, I'm going to tell you the solution, and then I'll tell you how did I think about that. Guys, if I consider x and y, can I say x plus y by 2 is greater than or equal to root xy? Because AM of x and y is greater than or equal to GM of x and y. That is, x plus y is greater than or equal to 2 times root of xy. Similarly, if you apply AM, GM on y and z, y plus z will come out to be greater than or equal to 2 times root of yz. And similarly, z plus x will be greater than or equal to 2 times root of z and x. And by now, it should be very clear to you that I'm going to multiply all the three. Just multiply all the three. And you get what you wanted. It is greater than or equal to 2 into 2 into 2, 8 into root x becomes x, root y becomes y, similarly z. That's all. Simple. Now, sir, how will we think that we should have done it like that? Guys, 2 points are there. Number one is your confidence. I knew that it is going to be done by AMGM. Why? I'm seeing that x, y, z are given to be positive. Whenever they are giving you that these terms are positive and question is of like something greater than something, like minimum value, it is going to be done by AMGM. So I was already confirmed, almost confirmed, the question is of about AM greater than or equal to GM. Second, I immediately realized that 8 is nothing but 2 into 2 into 2. And when I apply AMGM on this term, x and y, I'm going to get 2 here. I'm going to get 2 here again. I'm going to get 2 again. So I created this, and this separately and multiplied. Okay. So that was first level of good question. Now one level up. Let me show you the question first. Look at the question. Read it out. Take your time. Okay. This is like if you will try, you will try it. You take 30 seconds more. Just try to do it. I'm telling you, it's a question of AMGM. I'm giving you hint beforehand. Just try it. If you are able to do it, I'm really happy. If you can do this question, I must say you are like good at AMGM. Normally, it will trouble you. Okay, so if it is troubling you, no issues at all. It is a good question. In the first go, you will not be able to see how to apply AMGM, where to apply AMGM. But if you're able to do it, really good. You are preparing good. So before coming to this question, let me just give you the details of the course, and then I'll come back to this question.